Hello and Assalamualaikum everyone, and welcome to our presentation. Today we will be discussing about our project for course BDX 20902, Occupational Safety and Health. Our topic is Accident in Aircraft Manufacturing Industry, System Safety and Cultural Analysis. This is a cooperative study focused on factory floor, deviation, and global industrial crisis. This project was prepared by our group from University Tun Hussein All Malaysia, Section 1, under the guidance of our lecturer, Professor Madya IR Dr. Muhammad Hilmi bin Osman. Let's introduce the team member behind this study. Moving on to our team members, our group consists of 5 individuals working together on this research. We have Wali Muhammad Fakir, Siti Syahira Aina Muhammad Suaimi, Syed Firas Mukri bin Syed Zainul Asri, Muhammad Fakir Syamil bin Muhammad Khalis, Shime Khalis and bin Shasukama. Now that you know the team, let's dive into the background of our study. Now, let's look at the background and problem statement of our project. We have broken this down into the 3 core areas. First, socio-technology engineering. In high-risk manufacturing, maintaining proper OSH management is what stands between safe everyday operation and catastrophic failure. This industry rely heavily on complex process, barrier and strict engineering control. Second, the problem context. Unfortunately, modern industrial environments still suffer from containment, breach and near-miss incident. This usually happen because corporate value system frequently prioritize short-term commercial productivity over strict safety compliance. Third, normalization of deviance. This is a major issue where workers repeatedly bypass mandatory steps such as skipping physical lockout or layout sign-off or ignoring validation data just to reduce downtime. Over time, the position of the risk drop, leading to a structural vulnerability in the organization. Ultimately, there is an urgent need to analyze this human error and informal habit and use this to study to bridge real-world utility sector insight with the global aerospace failure. Thank you.
Thank you, Shime. My name is Syed Firas Mukri. Today, I want to go and present our project on how to understand and tackle operational failures in the industry. Our main goal is to look at why this breakdown happened and how we can prevent them. We have 4 main objectives. First, investigate root causes. We want to find the real reason behind accidents. We are not just looking at the surface level mistakes, but also the deep organization behavior and human factor that lead to big manufacturing breakdown. Secondly, is evaluate regulatory and environmental compliance. We need to make sure industry operation follow the law. In this project, we focus on Malaysian standards, specifically OSHA and Environment Quality Act 1974. Third, analyze behavioral factor. We will study why words sometimes take unsafe shortcut. Often this is caused by heavy workload, stress, or instance commercial pressure from management to hit target. Finally, develop a robust CAPA framework. We want to build a strong prevention plan. They include the instantly strict engineering control, hardening digital policies, and giving word to stop work authority to head operation if they see any dangers. Moving on to slide 2 to see how this objective apply in the real world. We are studying the Boeing 737 MAX crisis from 2018 to 2019. This tragic crisis caused 376 fatalities globally through the two catastrophic event. The crash of Lion Airline 610 and Ethiopian Airline Flight 302. These are two major issues we found. One, beyond the software, where the public focused heavily on the MCAS software glitch. For the forensic investigation show the deep issue, the root cause was actually embedded with Boeing corporate management and the manufacturing flaw itself. Number two, systemic flaw vulnerability because of intense commercial pressure to beat global rival. Production line were rushed, engineering change were fast-tracked, risk assessment were annulled, and critical warning from Boeing own internal engineering were dismissed just avoid production bottleneck. In short, profit and speed were put ahead of the human safety. Finally, let's look at the specific technical failures and operational blind spot in this case. First, hardware and software barrier integrity. This aircraft flight control system rely entirely on the data from the only single angle of attack sensor. This creates a critical single point of failure in complaint is completely broken the basic rule of aerospace engineering, which requires backup system in case on part failure. Second, store energy hazard. When that single sensor fail, the automate system took over the continuous force the one of the plane down. This create a massive kinetic control failure. The descent was so aggressive that the pilot physically could not override it. Third, train and operationally blind spot. To save the money on the expensive simulator training, Boeing deliberately chose not to include info about this new system in the pilot's manual. The pilot were flying blind. This cause proves that when organization get too compatible with routine cooperation, this create catastrophic safety gap. We must never sacrifice safety and regulation for commercial speed. That's all for me. Thank you.
Moving on to our next section, let's look at section 2.4, related legislation, focusing specifically on the Malaysian legislative alignment regarding OSHA and EQA. Under the OSHA context, employers have a strict statutory duty. According to Malaysian OSHA standards, they must maintain a safe working environment by ensuring proper information, instruction training, and continuous safety supervision are consistently provided to the workforce. However, looking at our case study, we can observe severely direct violation indicates under this act. First, there was a complete failure to document hidden technical hazard. Second, we noticed the suppression of internal engineering safety warning, meaning critical risks were deliberately overlooked. And finally, there was a clear negligence of essential workforce training on modified system, leaving workers unprepared for operational changes. This violate directly compromise the core principle of the workplace safety mandate by the law. Moving to section 2.4, let's look at Malaysian legislative alignment, OSHA and EQA. Under the Occupational Safety and Health Act, OSHA, Employers have a strict statutory duty to ensure a safe working environment. In this case, we see direct violations, a failure to document hidden technical hazard, suppression of safety warnings, and a lack of essential training on modified systems. Simultaneously, the Environment Quality Act 1974 (EQA) mandates strict containment to safeguard ecosystem from hazardous pollutants. The strict catastrophe release of aviation chemicals and composite industrial debris into public lands directly violates these environmental protection acts, providing that process safety and environmental compliance go hand in hand. Next, Section 3.0 addresses ethical and socio-cultural dynamics. On the left, we have ethical workplace responsibilities. Employer duty: safeguard workers from specialized hazards like chromate coatings, composite dust, and solvents. Transparency: cultivate a blame-free environment for reporting near misses. Reporting punishment with root cause analysis. Equal access: ensure uniform training regardless of background or language. Equal access. On the right, we face socio-cultural challenge. Workforce diversity. Hierarchy dynamics can prevent workers from questioning superiors about unsafe conditions. Language barriers. Communication gaps impact understanding intricate operation. Multilingual signage is key. Safety culture: prioritizing production target over safety erodes trust and reduce worker concentration.
Assalamualaikum. My name is Siti Sharaina, and today I will talk about the proposed action framework. Three-type corrective and preventive action (CAPA) plans. First, engineering controls, zero energy verification and redundancy. Eliminate single point of failure by enforcing redundant multi-sensor inputs. Implements physically interlock and hardware barriers to secure dangerous aerodynamic and mechanical energy state automatically. Second, administrative policy. Digital document hardening. Mediate formalist electronic cross signal for all technical engineering charge and factory floor quality discrepancy. Prevent informal communication habit from bypassing or erasing critical process safety records. Third, culture reform. Stop work authority. Establish a psychologically safe environment where any factory operator, engineer, or technician is empowered to install high-risk assembly line when an anomaly is spotted, entirely free from corporate reputation. Now I will talk about the discussion. Critical evaluation of systemic vulnerability. First, erosion of existing barriers. The manufacturer possesses standard quality checks and risk review. However, commercially production pressure effectively minimize their internal capability, treating critical check as a roadblock rather than viral protection. Second, SMS required for future aerospace. Modern Safety Management System (SMS) must provide secure, independent report channel for tech floor operators and engineers to flag human error and technical variation before they turn into major disaster. Third, lastly, regulatory oversight limitation. External authority rely too heavy on internal self-assessment provided by the manufacturer. This reduces the independent verification of complex systems and highlight the need for unbiased regulation tracking. That's that from me. Thank you.
Assalamualaikum and good day everyone. My name is Wali Muhammad. I will be presenting the conclusion of our analysis on accident in the aircraft manufacturing industry. In conclusion, aircraft manufacturing accidents are rarely caused by a single technical failure. They usually happen because of a combination of production, pressure, poor communication, and unsafe practice becoming normal over time. Another important lesson is that safety rules must always be followed, whether it's ignoring lockout, tagout procedure or skipping safety checks during aircraft production. Both increase the risk of serious accident. Finally, ethics should always come before productivity. Companies should never sacrifice to save time or reduce cost. The tragic loss of 346 lives remind us that every shortcut can have irreversible consequences. Therefore, safety must always be the highest priority in the aircraft manufacturing industry. Thank you.